Currently, 80% of the world's energy comes from fossil fuels. The Earth's reserves of fossil fuels are finite, and as civilization's energy needs become greater and more diverse, they continue to dwindle. This poses a serious threat to future generations, but heavy reliance on fossil fuels directly impacts society today. The United States spends over $300 billion per year on imported oil. Now, contrary to popular belief, only 8% of that goes to Middle Eastern countries. However, that still amounts to close to $40 billion going to countries such as Qatar that fund terrorist organizations. Domestically, solar power employs 43% of the U.S. energy industry despite providing less than 2% of the country's energy production. So, transitioning to greater reliance on solar energy would create far more jobs than it would cost the fossil fuel industry.
Solar energy has a huge potential of growth and efficiency that has not fully been tapped into. Currently, about 85% of the total energy consumption in the world comes from fossil fuels. These fossil fuels are very efficient at producing energy. However, these resources are finite and create pollution. On the other hand, the sun is non-polluting and has the potential of producing 10,000 times more commercial energy than humans already use. Photovoltaic solar panels and solar energy air conditioning systems are two projects that have been tested by engineers to solve the energy crisis. These solar panels can be installed on nearly 87% of rooftop space, producing an average of 13 to 17 million gigawatts an hour each year. Engineers found that the solar air conditioning systems work at 98.5% efficiency, which is better than commercial air conditioning.
There are three innovative solutions to the solar energy problem that could, when coordinated with each other, make solar energy a more efficient and thus more economical source of energy. Using silicon nanocrystals in solar cells could increase the quantum yield of electrons obtained per photon of light absorbed. Usually, the absorption of a photon by a solar cell releases only one electron, but with nanocrystals, it could release as many as 3. This is due to photons of blue or ultraviolet light, which have more energy than photons of other light. These nanocrystals could more than double the efficiency of solar cells at a cheap price. Through the use of multi-layered solar panels, energy efficiency is increased by widening the spectrum of light that a single solar panel can absorb. These panels have multiple layers of different compositions, which absorb ultraviolet and infrared light in addition to visible light, and yield more electrical power. In a 4-layered version, efficiency reached 46%. Additionally, light sensors can be used to track the location of the sun to increase efficiency. This allows solar panels to track sunlight and adjust to absorb a larger quantity of energy compared to a static solar panel. While static solar panels obtain maximum power output only when the sun is facing the panel directly, sensor-monitored panels calculate how to adjust such that they are always perpendicular to the sun. Through the use of these technologies, solar panels will become efficient enough so that they can better compete with fossil fuels and be an economical energy source.